Okay, we want to consider this jump question 1997, question 11. A uniform light beam XZ is hinged at S and kept in equilibrium by the force T and F as shown in the diagram above. If XO equal 20 cm and OY equal 30 cm, express T in terms of F, meaning make T the subject of the formula. That is what they are telling us to do there. Okay, now we are given four options, but one will be good for the solution. Now, to do this, we have to consider the two conditions under static equilibrium. Please don't forget the two conditions. The first one is that the net force must be zero, and also the sum of the torque will also be zero. The sum of the torque will also be zero. It means that you must be able to fulfill these two conditions under static equilibrium. Now, to resolve this very one, we have to. There was a situation I saw before using the two conditions, but this first one in particular was not able to give me the right solution to the very problem. Okay, I will have to do away with this first one and make use of the second one in this very one here, in this very question. Okay, now to do this using the second condition, I will have to determine the axis of rotation. I have to determine the axis of rotation. Okay, that is very important. That is very, very important. Now, to determine the axis of rotation, means that my point of rotation is going to be at x. The point of rotation here will be at x. This one will be the axis of rotation. This very part here will be the axis of rotation. This very one here, this is the axis of rotation at x. Okay, now we cannot proceed. We cannot proceed. Let us see what we need to do there. Let us see what we need to do there. Okay, now to do this very one, we have to determine other bodies, other forces, that will also be on this very system. We need to determine other force that will be on this very system. Let us determine other force that will be on this system. Okay, to do that, we have to bring out the y component here. We have to bring out the y components. Okay, we have to bring out the y components. The y components. Okay. Now for this one, I will have t sine 30 degree. T sine 30 degree. Okay, at this part here between O and S, there are, I think we're supposed to have t cos 30 degree here because this t will have effect here. We also have effect here. Now I want to use the second condition. I think this one will not be necessary, meaning I don't need to make use of this very one, this t cos 30 degree. If assuming now we are using the net force, I think this one will be useful. But now that we are not using the net force, let me forget about this t cos 30 degree. That is to say, yes, supposed to be t cos 30 degree, but I will not be using it. I will only use this very one here. Now we are using the second condition. Please don't forget I said using the second condition, which has to do with the sum of the torque, meaning we have to determine the axis of rotation. This is the axis of rotation here at this very point. At this very point here, we have the point of rotation. It means that this body will rotate at this very point here. Okay, now to do this, we have to consider the force. Now let us consider the force in this very body. We want to consider the force in this very body. And the two forces are simply this one here and also this very one. We are going to consider these two forces here. Okay, now this one is moving up and this one is moving downwards. Okay, now for this one that is moving up, it means that if I should push this body up, it means that it's going to move in this manner, it will rotate in this direction, therefore producing a positive torque. A positive torque. Let me call this one T1. And at the end, also we have to also consider this very one, also this very one, this F, meaning this one is downward. That is to say, if I should push this body down, it means that it will move in this manner. It means that it will produce a negative torque here. Let me call this one T2. This one will produce a negative torque. Let me call it T2. Okay, now to do this now, I can now consider the sum of the torque. And the sum of the torque now, which one is positive in this very one? T1 is positive, T1 is positive, and this one is negative. Therefore, I will have T2 here, that is to say minus T2. Don't forget, according to the conditions, that the sum of the torque must be 0. Therefore, I will have T1 minus T2. Now take T2 over, become T2 equal T1. Okay, you can see we are already talking what we wanted there. Okay, now we can now say that the formula for torque is simply the product of force and the distance. Okay, now using this very formula to solve this very work, it means that I will have to use the T2 first. The T2 now has to do with this very one here, which is the F. Okay, now if this body should rotate in this manner, this very body should rotate like this. It means that what distance we cover as this body is going to move at this point of rotation here, what distance will it cover this T2? It means it will cover 50. Look at it. It will cover this very distance here, which is 20 and 30, and therefore it's going to be what 50. Therefore, for this very one now, I can say that F is F times 50. I will have F times 50, and we don't work with centimeter. Remember what we have here, we are given in centimeter. We don't work with centimeter. Now, what can we do here? We can convert to meter. Therefore, divide by 100. Convert to meter. Divide by 100. Okay. Why the other one? Let's also consider the other one. This one is T1. Now, which part is T1? Which is this very one here? This one is upward, and it will move and cover a distance of 20 cm. Therefore, for this one, what is the force there? We have T sine 30 degree, T sine 30 degree. Now, times what is the distance it will cover? Is going to be 20 cm. And we don't still work with cm, we convert to meter. Therefore, I will divide by 100. It means that this one here will kill this one here. This 0 here will kill this 0 here. Now, what will be left is going to be F times 5 over 10. And write this part here, and sine 30 is simply half. It's simply 1 over 2. Okay, now what we left here is 2 over 10. Okay, we can still proceed. This one, 5 here is going to be 1, 5 here is 2. Therefore, I will have F times 1 over 2. Okay, what about this part here? I think I will have times half. Okay, and what is here? 1. Okay, here will be 5. Don't forget, 2 here is 1, 2 here is 5. I will be having 1 over 5 in this very one here. It means that this one will keep this. Therefore, I will have F equal 1 T times 1 over 5. And T times 1 is simply T. Okay? All over 5. Then this is what I have here. This is what I have here. Therefore, I have to make this 1 over 1 so that the end say T times 1 is T, 1 times 5 is 5. Therefore, I will have this. Now, they are asking us that we should express T in terms of F. That is to make T the subject of the formula. In this very one now, you can see that F is the subject here. To make T the subject, I will have to cross multiply. And the end, I will use this one here to times this. This one will also times this. Now, T times 1 is going to be T. And F times 5 is going to be 5F. Okay, can you see now that I have used this second condition and I determine my answer? I'll be able to determine my answer. You can see very well that the answer is option D. The answer is option D. It means that option D will be the best option there, of course, for the solution. Okay, now I can conclude at this point and say all the best. Please don't forget to like my page, Facebook page, GB Jumbo Online Mathematics, and also subscribe to my YouTube channel, Mathematics Science Mega Tutorial. All the best.